Okay, let's get started with the demo. Okay, so here we have a world. Right now it's just trees and sky and grass. But it's telling me to look behind me. What could that be? Oh, I'm sorry, I forgot to introduce myself. My name is Nate. My hometown I was originally born in Thailand. I was raised in the state of Virginia in the US. And my background before coming here was I was a recent graduate from university as an economics major, where I did learn a little Python, but I did want to branch out a little more with coding. So I decided to join Chrysalis to gain skills as a full stack web developer and become a software engineer in Japan and do something that's completely different from the normal path. And just a random fact about me, my favorite food's curry, all kinds of curry, including Japanese, Thai, and Indian. Okay, so without further ado, let's get started with the presentation. So first I'll be giving a brief introduction of VR, and also some differences with other technologies like MR and AR. Then I'll be giving some applications of VR, including like the history and like what we would use it for these days. The third thing I'll talk about is the implementation using the A-frame and some demos I did with implementation. And then last but not least, I'll be talking about the future, what's in store for us with VR. Okay, so first I'll give an introduction. So first, what is VR? So basically, it's like an immersive environment where you would have a headset and you can look 360 degrees. Everything is artificial with the environment and objects. So in this case, this guy is in a boring warehouse, but once he puts on his headset, he's in this nice room next to the beach, with everything being artificial, of course. So one of the main misconceptions is trying to get the difference between VR, AR, and MR, so I'll be explaining that now. So first, AR, augmented reality. Augmented reality they're still virtual objects, but it's in a real setting. So in this case, Pokemon Go, you hold the camera around, and it's a real environment. But there are artificial objects like the Pikachu and the Pokeball. And then MR, mixed reality, that's basically like kind of an enhancement of AR. It's still in a real environment, but the objects, while they're artificial, they're much more interactive. So like in this case, you can kind of like, even though the globe is artificial, you can interact with it, like you can move it around, and yeah. So that uses various devices, including HoloLens, which there will be a talk about that soon, so I highly recommend checking that out. So with that, I want to tell you about the goal of this presentation, which is to debunk some of these misconceptions. That VR is too expensive, that the implementation is too difficult, and it's just too far into the future. Like we're not ready for VR yet. But I want to show that those are not true. I will show you that VR can be one of the most accessible things you can do. While AR is also accessible too, VR can be as accessible as you want, but also you can challenge yourself as much as you want. So now I'll be talking about some applications of VR. So first I want to get into the history, because people see VR as something of the future. But it's not just something that's happening now. It's actually something that happened in the past. So in this case, there's Sensorama, which came out in the 60s. It basically has you in this machine that basically bikes you through New York City, and it makes you sense things like the smells of like New York. It's really different from today's VR, but it's technically a virtual environment, so technically you could say it's VR. And the cameras used for VR the headsets were like that, really bulky, completely different. But then once we got to more the 80s, the VR headset starts to look more like today with goggles, and yeah, but that was more in development, like experimental. We didn't really see much commercial goods yet that were related to VR, but that all changed with Nintendo's Virtual Boy. People forget about this a lot, but Nintendo tried to get into VR in the 90s, but it was kind of a disaster because it's looked so hard to use, and once you actually use it, everything's in reds like that, and you get headaches like after 10 minutes of using it, so it was a disaster. But so as a result, many other companies felt, oh, we're not ready for VR yet. That it's too soon. So that's what kind of caused some of the misconceptions and why we didn't really hear much from VR until 2012 when the Oculus VR came. This was Kickstarter funded, but through crowdfunding. And then once this became popular, we're now in today's situation where there's all kinds of headsets. Like there's the super high-end Oculus VR and HTC Vive, and then there are the really cheap ones like the cardboards, which the cardboard is also one of the easiest ways to access VR. So normal headsets are extremely expensive, like the Oculus is hundreds of thousands of yen. But with a cardboard, you can easily get one on Amazon for like 1,000 yen. And not just Google's cardboard, but all kinds of different cardboards. So basically how it works is you just plug in your iPhone and put it on and use an app and you're all set with VR. It's pretty basic. So what can we actually do with VR these days? So by far the biggest use for VR is games. Every console now has some form of VR, like the PlayStation VR. Nintendo learned from their mistakes by creating the Labo VR. And most game companies are investing somewhat into VR. Like Valve, they finally revived their Half-Life franchise after like 20 years just for VR. So it shows that it's not just a fad. There's still a lot of development going on, and it's only going upward from here. But of course, VR is not only for games. There's also experiences that can be had, like while not having to physically go places. Like for example, you can have theaters where you watch with friends, One Punch Man. You can watch concerts, and you can even visit places. Like in this case, Trailscape VR. What you're actually doing is you're just walking in place on a fake bridge, but it shows like a real like mountains, and it's kind of amazing. So like tourist companies could use this as kind of like a trial and error. Like, oh, if you go with us, you can go to these kind of places. So it's a really good way to show places for people who can't travel or who just want to see it before they make the commitment. Of course, it's not just play. Many companies use VR for job training, interview practice. For example, like, let's say you have an emergency situation where there's like a big fire and you have to escape. Those kind of situations you can't practice in real life, so you have to use VR to kind of to have like a simulation of the practice. And especially for medical reasons, VR can be extremely useful. Like when medical school students practice surgery, you don't really want to get things wrong with doing surgery in reality. So if you use VR, you can practice with ease and safety. So next we have conquering phobias. So here are some apps that you can use to conquer your phobias. Arachnophobia, basically that just has spiders shower on you. That's really fun. And there's also the Ritchie's Plank VR, which has you on a plank 500 meters up in the sky. Yeah. So have fun with those games. And the next, and last but not least, public speaking. Public speaking is one of the biggest phobias out there. There are a lot of people who aren't comfortable with it especially because they haven't experienced it before. So I feel like this app would really help with taking the first step into public speaking. And once you get practice more and more, you'll eventually be able to try it in real life.
Is that a real app?
Yeah, it's a real app. It's called Virtual Speech. So without further ado, now I want to talk about the implementation. How to actually code in VR. And I'll show you that it's actually pretty simple to get started. And there are just endless possibilities of what you can do. Okay, so I'll be introducing A-Frame, which is a VR framework that uses HTML. It's directly taken from the 3.js API, which is basically a 3D animation library that so you can set like 3D objects, 3D environment with 3.js. Yep. So first I'll show you how to get started with A-Frame. So first you make an HTML document with the head and the body. And then in the head you add this script so that you can import the A-Frame. And then in the body you create an A-scene to actually render what you want to do. If you want to add images, within the body you can add assets. And then for objects, there are many preset objects that you can use for A-Frame, including box and sky and plane. As you can see, the sky, it sets like the background, you can set the color, all kinds of things. The box, it sets a box. A-plane, it sets the flat surface that can be used for like a ground. In order to test your projects, I highly recommend running a local server instead of just using the HTML file. And the easiest way to do this is just run Python M simple HTTP server, and it'll direct you to a local host that you can test your projects. So primitives are basically built-in entities, which are container objects like the box and the sky. Components can be attached to these entities. So there are many preset components like position, color, animation, but sometimes we want a little more customization. So that's when we use JavaScript to make our own components. And to do that, we would call aframe.registerComponent. And if we want to make our lives easier by sorting out complex applications, we can use A-Frame React, which is basically similar to React, in which you manage the state. So for example, here's a basic structure of the entity component system. So here we have a car entity, and it could be divided into 3 components. The material component, which could have properties like color. The engine component, which could have properties like horsepower, and then a tire component. If you remove the tire component, it could become like a boat. And if you add like a wing component, it could become a plane. It's a little simplistic, but it makes you understand kind of the structure of what's going on with entities and components. And also one of the most important components is the position component. This uses a 3-dimensional axis with the x-axis being right versus left, y-axis being how high it is or how low it is, and the z negative actually represents in front of you, and positive represents behind you. And the position can be represented with x, y, z string attached. So let's get started with another demo. So here we have a solar system. The Earth is rotating slightly to kind of make it a little more realistic with the moon. And we turn around, we can see Mars way in the distance. So here's some of the source code I did. So let's go with the steps I said in getting started. So first we create the HTML document. Second, we import A-frame in the head. Third, we add ascene to render everything. Fourth, we add A assets. So in this case, I added textures as images. 5, we add primitives and entities, like the sky. In this case, I added an entity that wasn't built in. I imported it in the head. It was the stars, star backgrounds. And then yeah, try running the local server using Python. Or you can use Node serve. So now I want to talk about another animation library that you can use called Anime.js. So there's a built-in component called animation that uses Anime.js, but if you want more features, when you build your own component, you can invoke aframe.anime, which I will show you in the next demo. So here we have a world. Right now it's night. Wait. Oh, the sun's rising. It's morning, yeah. And now the sun's up. It's daytime, it's noon. But it's not gonna last for long because it's getting dark. And now it's night. And then the sun should rise again in the east. Oh, there it is, yes. Okay. So in order to do that, I built my own component called sun. And then in order to do that, I registered the component in JavaScript. And then I called aframe.anime to kind of set where the sun would go. Some alternative frameworks you can use and APIs include WebVR, which basically sets up whatever headset you want, including Oculus, HTC Vive, in code so that it can be compatible. A-Frame does use WebVR a little, so I highly recommend it. If you go deeper into it and you want to get your own headset, that's when you can use WebVR. And there's also React 360, which is developed by Oculus. It's React, except it's rendered in 360 degrees. So if you're a fan of React, highly recommend that. So overall, I mean, it didn't take that long to understand A-Frame and write that code because A-Frame is extremely accessible. I highly recommend it if you want to just start out. Oh, I want to make a VR world. Just go ahead and start with A-Frame. Just import the A-Frame component and just try to create a world. So next I want to talk about what the future entails for VR as VR users and developers. So some of the challenges we must face includes cyber sickness. It's not as bad as Nintendo's Virtual Boy, but there can still be problems as you adjust to a new surrounding, including just a new surrounding in general. But I feel like as the worlds get more immersive and more realistic, that will make it so that it'll be easier to adjust and you'll get less headaches. Another problem is resolution, especially for more realistic environments, like in this case Tokyo. You can see these weird lines even for a higher end headset like Oculus. But I feel like this will gradually improve over time, so we can look forward to the future. So some of the things we can look forward to the future includes VR's integration with AI. So, for example, the earlier example I mentioned about companies helping employees experience like a fire situation, like what do I do? How do I escape? If there's AI integration, then the machine will gradually learn like how the users interact with the system, and the fire will gradually get smarter, and you'll have to try to get away from it. And yeah, so it'll teach you all kinds of different ways to get around, which could make it more realistic. So next I want to talk about what the market will be like. So I feel like right now the market is mostly divided between the higher end headsets like Oculus and HTC Vive, and the gimmicky headsets like Cardboard. Cardboard is an extremely easy way to actually get into VR, as it's only like 1,000 yen. But it can also be a little uncomfortable to wear, and it's kind of hard to handle. So I feel like there will gradually become a balance between the two. So right now there's like Samsung VR being developed and being released, which it costs around like 5,000 yen, but it's also made of much better material than the Cardboard. So once you test out the Cardboard a little, that's when you can try more advanced headsets. So anyway, that's it. Thank you for watching. Here's some of my contact info. If you have any questions or you want to just connect, here's my information. And yes, thank you.